Steam flows through a nozzle at a mass flow rate of 0.1 kilogram per second with a heat loss of 5 kilowatt. The enthalpies at inlet and exit are 2500 kilojoule per kilogram and 2350 kilojoule per kilogram respectively. Assuming negligible velocity at inlet and the velocity C2 of the steam in meters per second at the nozzle exit is corrected to 2 decimal places. So we need to find the value of C2, that is the velocity of steam at the exit of the nozzle. So for nozzle flow, we can write the steady flow energy equation as specific enthalpy at the inlet, that is H1. 1 represent the inlet of nozzle and 2 represent the exit of the nozzle, plus the kinetic energy, that is C1 square by 2 at the inlet, plus the potential energy at the inlet, Z1 into G, plus change in heat with respect to mass, which is heat transfer per unit mass of the system, that is equal to enthalpy, specific enthalpy at the exit, plus the kinetic energy at exit per unit mass, plus the potential energy at exit per unit mass. So Z2G, G is the acceleration due to gravity, plus the work transfer per unit mass. So let's write dW by d. Now for nozzle, Z1 is equal to Z2. So these two terms will cancel out each other. And in the problem it's given that inlet velocity is assumed to be 0. So this term will go to 0. The work transfer is also equal to 0. So we can write C2 in terms of these equation now. So let's write here. C2 square will be equal to 2 times of H1 minus H2 plus dou Q by dou M. Now all the values are given in the problem. We just need to substitute. Okay. So this is equal to 2 times of H1, that is 2500 kilojoule per kilogram minus 2350 kilojoule per kilogram plus, now the value of heat transfer given in the problem is minus 5 kilowatt divided by the mass flow rate is given in the problem 0.1. Okay. So this value will come out to be C2 square will be equal to, so this entire value will come out to be 200 kilojoule per kilogram. So if we calculate C from here, that is C2 will be equal to square root of 200 into 1000 joule per kilogram, that is meter square per second square root. So we can write here meter per second. Okay, so C2 will be equal to 447.21 meter per second. Now let's go back to the problem and fill in the blank. So the velocity of steam at the exit of the nozzle will be 447.21 meter per second. To get more insight on nozzle flow, you can refer to the NPTEL course lecture number 21, Nozzle Flow, by Professor Vinayak N. Kulkarni of the Department of Mechanical Engineering at IIT Guwahati.